I want to demonstrate the ideas that we were talking about in this lesson regarding rolling a die 5 times and getting a sample mean, and then repeating that experiment and getting another sample mean. So we'll have plenty of sample means, and then we want to look at how those sample means are distributed. We'll do the same thing with variance, and then we'll do the same thing with proportion. And this should actually be the proportion of, I changed this to odd numbers. So we'll look at the proportion of odd numbers. So let's first look at the mean. Now what I've done is I've counted up all the 3.4s and all the 4.2s and all the 2.6s and all the 3.4s, so all these sample means, and place them into a histogram so that the height of the bar over that sample mean tells you how many of those sample means there were. So for instance, it looks like there was probably about 3 of these 2.2s here. Probably 3 2.4s, about, what is this, about 24, that might be 3.5 there. So you can see from this graph that this is approximately bell-shaped, which is what we were talking about in the lesson, how the sample means are normally distributed. The same thing should happen with the variance. However, you'll see, so if I click over here on my variance tab to look at how that graph is, or rather, let me just point out what we're looking at next, is these variances and how they're distributed. So if I come here to my variance tab, now we said in the lesson that the variances should be normally distributed, but this doesn't look very normal. So what we'll talk about in the next section is how can we make this look more normal. There's something we need to do with our samples to make this more normal. And once we do that, we'll see that the variance will actually follow more of a bell-shaped curve. The proportion, though, is a better example of something that's bell-shaped. So here you can obviously tell that the sample proportions from our experiment, so let me just point out we're talking about counting up how many 0.2s there are, how many 0.6s, how many 0.2s, how many of each of those proportion of odd numbers there were, counting them up, and then putting the height of the bar to represent the number of those proportions. So this is clearly more bell-shaped. The variance has some trouble at this point getting to bell-shaped, but we'll look at that in a minute, in the next lesson. But the mean also looks fairly bell-shaped. Now we can repeat this entire experiment with just a click. I can reload all these random numbers that I chose to be my dice rolls with one click. So let me just redo the entire experiment and now go look at my mean. Still looks fairly normal. Variance is still having some trouble. The proportion still looks normal. So let me just keep repeating that experiment over and over again, and let's see what happens with the graph here. This is my proportion graph. But every time I repeat the experiment, it looks like it stays pretty normal. Variance, though, is going to have trouble if I do this. Repeat, repeat, repeat. That one's not too far from normal. The mean looks pretty normal. Well, in some cases, it can get pretty far from normal, but most of the time, most of the repeats of this experiment looks pretty normal. So in the next section, I'll look at another Excel file that will show how to make all of these look more normal, including the variance, which at this point looks fairly far from normal.